Chronic inflammation is the hidden driver behind almost every major disease: heart disease, cancer, Alzheimer's, autoimmune conditions. And what most people don't realize is that your grocery cart is one of the most powerful tools you have to fight it. So today I'm breaking down 7 foods backed by real clinical research that have been shown to measurably reduce inflammation markers in humans. Not mice, not cell studies, humans. And the first one might surprise you. Food number 1 is bone broth. Let's start with bone broth specifically because it's one amino acid that it's loaded with called glycine. Glycine is the most abundant amino acid in collagen. And when you simmer bones for hours, you're extracting it in significant amounts. A single cup of well-made bone broth can deliver 1.5 to 3 grams of glycine. So why does this matter for inflammation? Well, glycine is a potent inhibitor of pro-inflammatory cytokines. It works by activating glycine-gated chloride channels on immune cells, essentially putting the brakes on macrophage activation before inflammation spirals out of control.
Inflammation is not a normal response to injury. Macrophages, these are the first responder cells of the immune system. They're just like the first responders out there in society, the ambulances, the fire trucks. They have a dual role, and they get activated to show up and clean up the mess, or they get activated to draw their weapons out and start shooting because some infection has gotten involved. That's really the only purpose of inflammation, is the first response to infection. So as you say, why does that happen? Yeah. It happens because there's no trigger lock on the guns that these cells will draw. So glycine is just the natural trigger lock.
In laboratory studies, glycine has been shown to suppress inflammatory cytokines like TNF-alpha and interleukin-6 in adipocyte cells, 2 of the most well-studied markers of systemic inflammation. And a separate randomized controlled trial in patients with metabolic syndrome showed that glycine improved antioxidant enzyme activity over a 3-month period. What's notable is that glycine is genuinely deficient in most modern diets. We eat a lot of muscle meat, which is high in methionine, but we've lost the nose-to-tail eating patterns that used to balance out with glycine-rich connective tissue and bones. Now, bone broth is one of the simplest ways to restore that balance.
Then why is inflammation worse now than it was for previous generations? Because previous generations, they used to throw the bones in the soup instead of the trash.
Food number 2 is fermented foods. I want to talk about a specific study here because it genuinely shifted how researchers think about gut inflammation connection. In 2021, a landmark trial led out of Stanford by Dr. Justin Sonnenberg and Dr. Christopher Gardner, published in Cell, divided participants into 2 groups. One ate a high fiber diet, the other ate a diet rich in fermented foods, specifically 6 servings per day of things like yogurt, kefir, fermented cottage cheese, kimchi, kombucha, and fermented vegetable brine. Here's what happened. The fermented group showed a significant decrease in 19 inflammatory proteins, including interleukin-6, and greater microbiome diversity. And the fiber group, their inflammatory markers didn't decrease the same way. The conclusion was striking. Fermented foods appear to actively downregulate the immune system's inflammatory response, likely through the short-chain fatty acids, postbiotics, and live microorganisms they introduce into the gut. One standout from the study worth highlighting is kimchi. It's non-dairy, widely available, and loaded with lactobacillus strains that have independently been shown to modulate gut immune function. If you're not eating fermented foods regularly, even a small serving of kimchi a few times a week is a meaningful place to start. I do a spoonful of sauerkraut daily, and my husband and son eat fermented dairy daily as well. Third food, and this is where I want to get into some new, genuinely exciting research, is fish, specifically fatty fish and fish roe. Now, we've known for decades that omega-3 fatty acids, EPA and DHA, are anti-inflammatory, but the mechanism was kind of assumed to be the way they simply compete with omega-6s and reduce the production of inflammatory signaling molecules called prostaglandins. But new research has reframed this. EPA and DHA are actually precursors to a class of molecules called specialized pro-resolving mediators, or SPMs. And what SPMs do is not just reduce inflammation, they actually resolve it.
People thought that when inflammation has run its course, it sort of just like passively stops what it's doing. Because in physiology, things happen when you need them and then they stop. But then people studied what was happening during what they thought was this passive phase, and it turned out the turning off of inflammation is actually an active event. So resolution is the active turning off of inflammation. You could think about it the dimmer switch. So when you're inflamed, you're turning the switch up, but when you're resolving inflammation, you're turning it back down again. So together, these lipids that turn off inflammation have been called specialized pro-resolving mediators, or SPMs. Okay, so these include different families based on their structures. So we have resolvins. Some resolvins are made from EPA, some are made from DHA. We have protectins. They're made from DHA. And we have maricins that are also made from DHA.
They turn off the inflammatory signal and clear cellular debris. That's a fundamentally different mechanism. A 2017 study in the Journal of Clinical Lipidology found that fish oil supplementation in patients with peripheral arterial disease significantly increased the omega-3 index and several downstream markers involved in specialized pro-resolving mediator pathways. And a 2020 review in Frontiers in Immunology highlighted resolvins derived from EPA are key orchestrators of inflammation resolution. Now, fish roe specifically is worth calling out because it is one of the most concentrated dietary sources of omega-3 phospholipids, which are more bioavailable than the triglyceride form found in most supplements. Even a small amount, a tablespoon of salmon roe, delivers a meaningful dose of EPA and especially DHA in this highly absorbable form. Number 4 is turmeric, and I want to explain why it works because the mechanism is genuinely fascinating and tells you something about inflammation itself. One of turmeric's active compounds is curcumin, and its primary anti-inflammatory mechanism is the inhibition of NF-kappa B, nuclear factor kappa B. NF-kappa B is essentially the master switch for inflammation in your body, and when it's activated, it triggers the transcription of dozens of pro-inflammatory genes, cytokines, enzymes like COX-2, and inflammatory mediators. It's the pathway at the center of almost every major inflammatory disease. Now, curcumin blocks the activation of NF-kappa B at multiple steps in that signaling cascade. And a randomized controlled trial found that 1,000 milligrams of curcumin daily significantly reduced CRP, interleukin-6, and TNF-alpha in patients with metabolic syndrome compared to a placebo. And a 2021 meta-analysis of 32 randomized controlled trials published in Nutrition Reviews found that curcumin supplementation significantly reduced inflammatory markers, including CRP and IL-6, across pooled human studies. Now, the catch with turmeric is bioavailability. Curcumin is poorly absorbed on its own, so pairing it with black pepper can increase its absorption by up to 2,000%, according to a foundational study, or using whole food turmeric with dozens of other beneficial compounds is also a great way to go. Number 5 is extra virgin olive oil. And the compound I want to highlight here is oleocanthal. Now, oleocanthal is a phenolic compound in high-quality extra virgin olive oil that acts as a natural ibuprofen. It inhibits both COX-1 and COX-2 enzymes, the same pathway targeted by NSAIDs. Now, this isn't a metaphor. It's literally the same biochemical mechanism. A study published in Nature first described this effect, noting that the burning sensation you feel at the back of your throat from good olive oil is actually oleocanthal. Now, a large clinical trial, the Predimed study, published in the New England Journal of Medicine, found that a Mediterranean diet supplemented with extra virgin olive oil significantly reduced inflammatory markers and cardiovascular events over 5 years. This is one of the largest and most robust dietary randomized controlled trials ever conducted. So aim for 2 to 4 tablespoons of high quality, cold pressed extra virgin olive oil per day. Number 6 is blueberries. Now, these aren't just a good snack. They're one of the most studied foods for inflammation reduction, largely due to their anthocyanin content. Now, anthocyanins are polyphenols that reduce oxidative stress and inhibit that NF-kappa B signaling similar to curcumin, but through a different pathway. Human clinical trials show that regular blueberry or berry consumption can reduce inflammatory signaling and, in some studies, lower inflammatory markers like CRP and IL-6, interleukin-6. Another study in the American Journal of Clinical Nutrition found that blueberry intake improved endothelial function and reduced systemic inflammation in healthy men. Now, 1 cup a day, fresh or frozen, both are effective and is enough to deliver a meaningful therapeutic dose of anthocyanins.
All of the polyphenols, great at absorbing free oxygen radicals. So if you can have a diet that suppresses oxidative damage or that doesn't do oxidative damage, you're going to get less inflammation even if you're glycine deficient. So all of these things are useful.
Number 7 is veggies, like dark leafy greens, and a special focus on cruciferous vegetables like broccoli, kale, and Brussels sprouts. Now, the reason cruciferous vegetables are in a category of their own is sulforaphane. It's a compound produced when you chew or chop them, which activates an enzyme called myrosinase. Now, sulforaphane is a powerful activator of the NRF2 pathway, or the NERF pathway, a master regulator of antioxidant defense and anti-inflammatory gene expression. It essentially turns on your body's own anti-inflammatory machinery. In a recent study, 30 grams of fresh broccoli sprouts reduced both IL-6 and C-reactive protein over 70 days, during which the sprouts were ingested, and a 2024 study also showed that sulforaphane reduced C-reactive protein in HIV patients. A practical tip is slightly undercooking your broccoli, because overcooking destroys the myrosinase enzyme. Or add a small amount of raw broccoli sprouts, which contains about 50 to 100 times more sulforaphane precursors than mature broccoli, to your meals. So there you have it. 7 foods, all backed by real human clinical trials, all shown to measurably move the needle on inflammation. Bone broth for glycine, fermented foods for microbiome-driven immune regulation, fatty fish and fish roe for SPMs, turmeric for NF-kappa B, olive oil for oleocanthal, blueberries for anthocyanins, and cruciferous vegetables for sulforaphane. The pattern you'll notice is none of these are exotic supplements. They're foods, and they work at the molecular level to regulate the same pathways pharmaceutical drugs try to target, all without the side effects, but with side benefits. So these are foods I work into my diet daily or weekly, and I hope that you will also try to make them a new habit. So if this was helpful, hit the subscribe button. I post new content every week on the science of food, longevity, and how to optimize your health. So drop a comment below. Which of these foods are you eating first?